So for Friday, I have two choices. This is gonna be like pick your own adventure. We can either do how venture capital really works, or we can do 100 rules of thumb from the world's best software engineers. Who wants the first one? Who wants the second one? Okay. I'll save the first one for the next class.
Yeah, second one, right?
The second one, rules of thumb from the world's best software engineers.
Are we all going to get little books?
I have 2 days to figure them out. Okay, let's go. So today's episode of this fancy this movie we're watching is going to be leftovers from previous lectures based on your various notes when I've asked you, what don't you understand yet? What are you still confused about? And we did a little bit of a sort and came up with these 3 topics as being things that people still want to learn about. Okay? So it's going to be about regular expressions, about sessions, and more about testing, in particular mocking. And we'll see if I get through all of them. Okay? So let's start with regular expressions. So who can define what a regular expression is? Okay, excellent. Oh, yes?
A pattern for identifying things in a string?
A string of text, exactly. That's all it is. Have you ever gotten a string input from anything and you're wondering, is this a valid email address? Is this a valid social security number? Is this a valid bit of HTML? Whatever. You can either write a real parser, but for quite a lot of the real world patterns that exist, you can just write. By the way, get your computers out because you're going to have a lot of fun in a second. For a lot of patterns, you can do regular expressions, which are far, far faster, easier, and simpler. And it's a tool that exists everywhere. For example, I'll show you one crazy one, and I'll give a Coke to the one who can tell me what this line of code does. Who can tell me what this line of code that I highlighted does? It's Ruby, first of all. It's valid Ruby. Okay, I'll take it apart for you. Oh, yes.
Well, I'm still working through it, but I think, the real regular expression is the thing at the end.
Yeah, regular expressions in Ruby are separated by forward slashes. Okay, so that's the inside there is a regular expression. That's correct.
And then, so star I know is usually a placeholder for anything.
Not in a regular expression.
Okay, well, I'm already wrong.
Yeah.
Done.
Wendon.
First, it takes the methods of the fixed noun.
Yes. One dot methods, because it's a dot something calls a method on the previous object, and the method is called methods. Okay, go on.
And I think the return value is an array of symbols. It's not string, so you need to turn them into string. So there's a map to S.
Yeah.
And now you want to find something in that array of strings, and the regular expression is dot will match all the characters, any characters to a dot.
Zero or n of that any character. Oh, dot star. Sorry.
Dot star is 0 or n, but star, but the start is any
character, exactly.
And star is 0 or more.
Yeah.
So it means that it's any message name with SP inside.
Exactly. Yes. Good job. Okay, so let me run it so we can look at it together because it's kind of interesting just to refine your.
What is the amp symbol in the map?
I'm going to show you. So here it is. He's right. These are all the methods to fix num which have SP in them. Okay, so let me start with one.methods, which is an array, as you can see, of a lot of methods that one has. And they're all symbols. You can tell that because it's colon. Now, I happen to know, because I used it as an example another time, that the .grep method, which is available on an array, only works on an array of strings. So the next thing I do is I do a map. Now, normally, you would have, let me just keep this so I can copy it. I didn't need it. Excellent. Let me go back here, copy it. Okay, let's do it this way. Whoop. One.methods. Actually, let me just do it like this instead. 1, 2, 3 dot map. First thing, who can tell me what this does? Okay, if you guys are going to talk, you should step outside because it is distracting. x plus 100. Who can tell me what this does?
Adds 100.
Say what?
Adds 100 to each element.
What is it? What does it return?
An array.
Yes, exactly. Okay, so you know that. How about if I do x to s? Well, it's similar. Converts them all to strings. So this notation, this weird notation, is a shorthand for map, but it can be used in a lot of other places. Instead of writing all that, you write ampersand colon 2s, which basically says in shorthand form, call the 2s method on everything in that array and apply. So just another shorthand. It's always shorthand. Yes.
Can you slide the window up a little bit?
Yes, I can. Sorry.
Sorry.
And I can make it bigger too. Okay. So then, finally, so now we know what this does, this part. Right? That returns us an array of strings with all the names of the methods. Then the .grep method is available on an array of strings, and it applies that regular expression to every element of that array and does not drops out the ones that don't match that particular regular expression. So, yep. So, so one thing about regular expressions is that you give them a string, and the first thing they do is they say yes or no. It matches the pattern or it doesn't. But the second thing they can do is they can actually extract bits of the string that satisfy certain characteristics. And we'll get to that in a second. So regular expressions are all over Ruby, all over Java, all over whatever language you want. It's a really good thing to learn, not only how to write them, but more importantly, when you can use them. Because you always go back to sort of experiment, because they're so powerful. It's a complete programming language, all in single characters. It's a really crazy language, but it's very, very powerful. Okay, now it appears other places. Who can try to tell me what this does? This is now in the shell. So here, oops. I left the F off, so I'm going to type that in. Okay. Anybody want to guess here? Any hands? So first of all, yes.
So the find method would
It's a shell command.
yeah.
Okay.
This shell command set will find files
Yep.
in, I assume, the current
Local directory, yes.
Well, it uses the option regex, I assume, for regular expression.
Yep.
And then the same as before, dot for any character,
Yeah.
one character,
Yep.
star for 0 or infinite, or
Yep. Yep.
literary characters,
Yep.
ST, but then the brackets, I think, group,
Yep.
what is inside. I'm not quite sure about the circumflex and the slash,
Yep.
but the star outside the bracket says that whatever is inside the brackets can occur either
Exactly.
0 times or more.
Exactly. Burke.
Yes.
Not slash.
Exactly. So it's basically anything followed by ST followed by anything excluding slashes.
Oh.
That's what that does. I have no idea. I tested this at home. There's a lot. So it was more interesting when I did it on my own computer, but it doesn't matter what it gives. You know, the find command is very useful, by the way, because if you were looking for, like, what, I'm going to go to cd mydev, and I'm going to do ls form demo, let's say. And let's say config.ru. So I can do here, I can do find dot, anywhere from here, dot name, config.ru, and it finds within, from here down the whole tree, all the files that are called config.ru. Okay, and so similarly, of course, if I could go regex, and I could say, oh, I don't know, something that I couldn't do, how about dot star, anything, followed by slash, followed by star, dot star again, demo, dot star. So those are all the files that have the word demo in them, either before or after the slash. That probably was overly complicated, but you get the idea. So these are, you know, there's a zillion Unix shell commands, and there's no way anybody normal can remember them all. And to be honest, I only researched this regex parameter on find because I had to explain this. But it's good to know it's there. If you ever have a difficult problem, Now, there's an interesting question, by the way, quick aside, on the trade-off between learning how to do a particular search with find using a regex and just doing looking through it by eye. You know, the tendency always, and I'm sure you've all gone through this, is you do something by hand, it's really slow, it's really inefficient, it's really like a waste of time. You know there's a tool out there that would make it easier, but you don't bother learning the tool. And that's not necessarily a bad impulse, because sometimes you take an hour to learn the tool to save you 1 minute, and that doesn't make sense. But to know it's there, and to know when the case comes up, when you've done something by hand a bunch of times, like for example, I have typed these commands in 1,000,000 times, particular, CD, CD6, CDC, CDU, and I learned how to do aliases, and I learned how to do a login profile, and now they're always there. So, you know, it's one of these things, don't go learn all the tools before you need them, because your brain will fill up, but be alert to when you're doing something manual over and over again and say, there's probably an automatic way to do this. Okay, so let's take a look. Everybody go to www.rubular.com. Oh, okay, ignore that. Everybody go to www.rubular.com. Let's play with it a little bit. This is a wonderful little tool that you will visit many times. So let's say I want to say, let's try to match a phone number. Okay, let's try to see how we match a phone number, an American phone number. Okay, anybody start? Look, here, by the way, if you scroll up, you see your quick reference here. Okay, so let me just go through this. Bracket ABC means A or B or C. Up arrow ABC means anything but A, B, or C. A-C is any letter in the range A to Z. Up arrow is start of line, dollar is end of line. Those are not so important. Dot is any character at all. Backslash S is any white space, digits, non-word. A or B, 0 or more of A. Sorry, 0 or 1 of A, 0 or more of A. Okay? So a phone number. What does a phone number in the US look like? Let's start with that. You got to first figure out what it looks like yourself. Come on, we all know it.
3 numbers, not a 0, not being 0.
Okay, so it's not 0. So it's not 0 followed by 3 numbers. Yeah, followed by
Not 0 followed
By 2 numbers.
by 2 numbers. Yeah,
Then another 3 numbers.
3
2
numbers. Oh, how about a dash?
Yes, dash, then it.
Could be a dash or a slash.
That's also
Number.
not 0.
Also not 0. Okay, not 0. I didn't even know that. 2 numbers. Another dash. We'll change that in a minute. And then 4 numbers. Is it again not 0? I don't even know.
No, it could be 0.
Okay, so 4 numbers.
The first 3 can't be 5 apparently.
Say what?
The first 3 can't be 5 because you know TV shows when it goes 5
Yeah.
5.
That's
So
apparently.
those the not 0 and the 2 numbers.
That's
Yeah.
not true though.
Or 5.
That's true, isn't it?
Well, it is, but if you dial 5551212, it's automatic directory assistance.
Right.
516.
Okay, let's stop.
It is a number.
Black hole alert, black hole alert. Okay, so here's the thing. So this is how you start thinking about, how you start thinking about writing a regular expression, right? I mean, similarly with an email. Like, what does an email look like in the most simple case? Spell it. Oh, not there. What does an email look like?
String, hat,
String.
string, dot.
Any characters allowed in that string?
Yeah.
Okay.
No.
Well,
No.
Alphanumeric characters.
Alphanumeric characters.
also periods.
Huh?
Periods.
Plus periods.
Underscore.
Plus underscore. At sign.
Can it stop the number?
Pardon?
Can it stop the number?
I think so, yeah. Okay, what else? At sign.
Hat, string, alphanumeric.
String alpha. Any punctuation required here?
There's a dot.
Just 1 dot or multiple dots?
Which one?
But I can say A dot B dot C, can I? Pedo at. Yeah. Okay, let's do the numbers first. So I just want to show you the thought process that goes into this. So let's do the numbers. Okay, so the numbers are not 0. Okay, start with that. So I'm going to go, okay, single character, not 0. So I'm going to go like this, start just as a test, followed by two numbers. So I can use this, this notation, that notation. So basically a number is, help me if you want, any digit backslash D, curly bracket, backslash D, close curly bracket. No, I'm sorry, wrong, like this. Backslash D, 3, 2, curly bracket, followed by a dash, followed by the same thing, not 0, followed again backslash D, curly bracket 2, followed by a dash, followed by 4 numbers, backslash D, curly bracket 4. So type that into Rubular and test it, and let me know if it works.
Ruby to this thing, this tool.
Rubular, this tool.
Yeah.
So basically I'm going to say, dash, dash D, curly bracket 2, dash, dash D, curly bracket 4, rather. Who can tell me if it's going to work or not? Who's far enough? Huh? No, try it. Try it in Rubular. Type that into where I typed it, and then start typing in some past phone numbers over here and see whether it seems to parse the phone number correctly. So type the phone number here. 123-123-123.
Yep.
It does work? See if you can find flaws with it. How can we improve it?
We can make the dash optional. And
Notice that as I'm typing, it's not good yet. Oh, it didn't work for me. What did I do wrong?
Yeah.
Actually, if you had the number there already,
Say what?
and you're typing the expression, it will be matching as you go. It will be highlighting the number.
Oh, it did match it. I'm sorry. I was, so 1, 2, 3, 2, 3. That doesn't match. It's not a valid phone number. 1, 2, 3, 4. 1, 2, 1, 3, 1, 2, 3, 4. Now it matched it. Now, what if I wanted to make the thing dash or slash? I never saw a slash in a phone number, by
Not
the way.
slash, but
Parent?
Yeah,
Yeah, you can
parentheses.
dot,
First one
maybe a dot.
in parentheses.
Huh?
A dot too. Oh, nothing at all.
The first can be in parentheses.
Okay, so first of all, this can be a dash, or a dot, like this. So now I should be able to put a dot in here.
Or nothing.
And it works. Or nothing. How do we do nothing?
Can you say one or the other as well?
How do we do or nothing? There or nothing?
Star.
Nope.
That's the question mark,
It's a
0
plus.
or 1.
Plus.
It's a plus, exactly. So now I can go, no, that's not right. What's wrong with this?
It's supposed to be a
Question mark
star.
for
A star.
0 or 1.
Because it could be nothing. And that's still be okay.
It's a question mark is what we want. Yes, it's a question mark. Because
Question mark is
0 or not,
Zero.
0 or 1, right?
Zero.
Optional.
well,
Yeah.
doesn't the question mark apply to this square brackets?
Yeah, so it's basically either nothing or dash or dot.
There's an issue with the not zeros though. You can put letters in as like your first. Yeah. Like you can do like A, 1, 2.
Oh,
A,
that
2,
works?
3, yeah.
Oh, why? Figure it out.
Because it's anything that's not a 0. Which
Ooh,
includes all
good point.
characters.
Good point. Okay, fix it.
Well, there's
You have a
another-
fix?
No, I have a question.
Okay.
Right now, if I put in just.
You guys think about how to fix it while I listen to this
I'm
question.
kind of
You
curious
can do
how
1-9.
Rubular, like how to read my Rubular match result. Because right now, if I put 2 phone numbers back to back in full,
Yeah.
It shows the whole thing as matching.
Aha.
So I don't know if that, like, does this match once or does this match?
It seems to match as many times as it finds the string.
Okay,
Yeah.
so you can duplicate. You can
Yeah, but there's
separate
ways
the
of
phone
preventing
numbers.
that as well.
Okay.
Okay, but let's go to, you have the answer, so what do I do here?
You do a 1-9.
In here?
Not 0. Yeah.
1 dash, oh, instead of
Get rid of
yeah,
that.
1 dash 9. And I guess the same thing over here, 1 dash 9. And now I can't put an A in here. Boom. Okay? And we can't put a dot. We can't put a dot here, so let's fix that.
If you add more numbers to the end, more than 4, I mean, I guess it doesn't accept the whole thing, but it'll sort of, it won't break it.
Well, I'll show you in a half a second. So now I can accept a dot here too. Okay? Now what you can do is you can say start of string, end of string to do what you guys want. So I can say \A, \Z. Now if I put another phone number here, doesn't match it. Okay? Because the last digit, the 4 of the first phone number, is not the end of the string.
So if there's a space in
What do you think? Tell me. You tell me.
match the first one.
No, because the pattern says I need
When I add Z, it doesn't match anything.
/Z,
Yeah.
capital Z.
I know, it doesn't work.
Yeah, me too.
Yours doesn't work too.
Mine works.
Take out one number and that's it.
Worked a second ago. Wait. Yeah.
Wait, what did you just change?
I made it a valid phone number. 123-213-1234.
Oh, okay.
Okay?
Can the last, okay, let's go back then.
Something wrong.
Okay?
The last one gonna be 0 to 9, the last 4 numbers.
Cannot be?
Shouldn't you write 0 to 9?
I have any digits. This one here, you mean?
Yeah.
That says any digits.
That means 0 to 9.
0 to 9. Any digit means 0 to 9. There's many different ways of expressing the same thing. I'll show you one more thing before I go on, which is, remember I said it can also help you pull things out? So what if you wanted to get the area code out of this thing? What you can do is, you can put parentheses around any subclause, which is here. And now, the first match group is 1, 2, 3. So it's pulling out the area code. Okay? And go further, and you can put another parenthesis around here. And the second group is now pulled out. Yes?
What if you wanted to make one
See?
character dependent?
Phone number? Yeah. Go ahead.
What if you wanted to make one character dependent on a previous character? Like if you have an open parentheses, you should have a closed parentheses.
Okay. We'll have an example of that. But it's very interesting for you guys taking computer, what is it called? Theoretical computer science or whatever that course is. This gets into finite state machines because that's how this thing is built, and deterministic versus non-deterministic, and what the limits are of what you can parse with a finite state machine. And so you can parse that, but you can't write something that does a complete matching braces to any depth. That exceeds its capability. So you can't write, I believe. Oh, I take it back.
It's not like a Turing.
It's not, but here I have to dance a little bit because classic regex cannot do that, but there's enough additional bells and whistles that you can actually do even more. But it has to do with finite state machines and what you can do with them, push down automata, all that stuff. That's how this stuff is implemented. I can also, who knows how to give the group a name? I don't quite remember that myself. Do I put a name here? No. No. Look for it. Regex named groups. Name capturing groups. Okay. Looks like it's question mark p tag. This is in Python. Take it back. Ruby name. Ruby. Oh, there's a phone number. How about that? Okay. Oh, interesting. At the beginning. All right, let's try that. See if this thing even knows how to do that. So this thing says that here I could put a question mark area code closed. Aha. And over here I can. You see how these things become next to impossible to read after a little while? Phone number. But see here, now it's not only pulling out these information, so obviously just to show you, put my own phone number in here, because you can put another string.
You have to get rid of A and Z.
What?
Get rid of A and Z, that will work.
I thought it would do multiple things as well.
And yes.
Yeah.
You're doing end of string, start of string. If you start of line, end of line.
Maybe that's it. Okay, let's try that.
Can you do?
And
Can you take A and Z in parentheses?
there we go. You're right. So this is really cool, right? So here we have, and these things are extremely fast also. So if you're like running through a database with hundreds of phone numbers, here it is, area code, phone, area code, phone, area code, phone. Okay? Now, if you look at whatever language you're in, including the shell, I'm sure, although it's very grody, there'll be a single call, like in Ruby, I forget what it is, match or something like that, which will produce a hash with this symbol and this value, symbol value like this. Okay? So, okay, this is a great toy, and you will use it often. Let's go back to the notes for the class. Okay, so, puzzle. Write a regex. Everybody do this. Write a regular expression which matches these, one regular expression that matches these strings but not these strings. Go. You have 3 minutes. Or 5. I'll give you 5.
There's no link to it. I'm trying to find it. Adventure.
If you have something you think works, wave at me. This is when we could use the light clicker. Looking for a pattern, right? What these strings have in common. Anybody getting close, or nobody getting close?
Close.
I think I got it.
Okay, let's hear it.
Like a caret, open tag,
Open what?
tag, like left arrow, dot, curly braces, 1 comma, close curly braces, close bracket, $sign.
Okay, what the hell does this mean?
It means
Read this to me.
Start of line, bracket, any character.
Wait, you're doing the wrong one, but that's okay. You're doing this one.
Oh, is that not what we're doing?
We're doing this one.
Oops.
one.
I did the wrong one.
That's okay. You still get partial credit. Yes, Burke, hit it.
Dot star.
I was going like, what? This is so weird. I'm so confusing.
Sorry.
Yes, it's okay.
Dot star.
Dot star
P dot T.
P dot
T.
T
Dot star.
dot star. So basically, you're saying any string that has a P, 1 letter, and a T.
And it
Superior-
has to be, P and T has to be lowercase.
Lowercase. PT, BT, BT. Ah, slap.
Slap too.
Oh, slap. Oh, I lit. You win. You're right. Slap 2. P, very good. Nice one. Yeah. Okay.
I mean,
You only get 3 claps.
mine
sorry.
isn't as nice.
Done 4.
but
Because this is interesting, because it's not about, in this case anyway, it's about really good pattern recognition in his head that he saw that pattern. Go ahead.
I did something very similar. It's
Yeah.
dot star P, but then I said basically just all the vowels or a
Uh-huh.
space.
Yep.
Because it was always vowels. So
Yeah.
I don't know if that was part of it too. So it was just P, and then brackets A-E-I-O-U
Yeah.
space, and bracket T
Okay.
star.
Oh, essentially the same thing.
So yeah, same idea,
Yeah. Okay,
but
great.
more specific.
Yeah. I mean, I think that the cheaty way to do this, I think would work, is this.
I did the GD way.
What's the cheaty way?
Yeah, like open bracket and then pit, tube,
Yeah.
spot, tube, spade.
Yeah, yeah.
That's
So
what-
get a tube? You call that a tube?
How do you call it?
Call it a vertical bar.
Vertical bar.
Sometimes it's called a, not a tube, but a
Pipe.
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 That's what I meant.
Yeah. That,
Uh,
yeah, exactly. That's the
Yeah.
cheat way of doing, but there's no cheating in software engineering. If it works,
it works.
and it's
Right.
short and elegant and fast, it's good.
You mean you mentioned all the words?
It's not short.
Yeah, all the words.
It's not short.
It's not short, it's true. So we can have a long debate going for hours which one is a better solution, but let's not.
Will that accept those?
Yeah.
Yeah, by
Okay.
definition.
Yeah. It's an infinite problem. So of course now we have the solution to the other one that we got from from Ethan, Evan, Ethan. I always forget your name. There's two names I always forget. Ethan, and the person that's not here.
How are you gonna remember their name?
He's on your team.
No, we know why.
My team, Samir.
Samir. Yeah. I can never remember Samir's name. Sorry. I mean, it takes time. Let's put it that way. So the next one we got anyway. It's basically exactly what was said before: angle bracket, some letters, close angle bracket. Really, you don't need anything more. It's open angle brackets, dot star, close angle bracket. Now, because it doesn't say what it should reject. I mean, for example, should it reject this? Well, our solution would not reject this, but I won't spend time on it. Finally, this is kind of a really real-world one, which is email address. And I put a whole link here because it turns out that email addresses. Let me just cut and paste this.
This is the official regular expression.
There's no. That's what's funny about it. There's no official because.
In one of our readings, I thought it said it was. That there was like an official one, but that official one was actually worse than the one. that
Exactly.
came up with.
Well, the official one is really long and it's it's linked there, right there. You're right. So this is the one. And if I say pedo@brandeis.edu, didn't work. Why not? What is this \b doing here? Okay, let's decode it. What are they wrong here?
The \b is any word boundary.
No matches. What? Okay, now we have to look at this. I just copied it. What's wrong with it?
Why is the uppercase after dot?
Ah,
It's all uppercase.
yeah, it's not. That's incorrect.
It should be lowercase.
Either one.
I mean, either one, but.
I think you can do this.
Also,
That's what the official
for
is.
the-
They're gonna
also
make it
for-
insensitive by adding I.
Where? On the whole thing. I think there's a
Yeah, a lowercase
over
I.
here. I think I.
insensitive.
Yeah.
Right.
So, but the reason is, and I'll leave this to for your edification, is if you read this whole article, it talks about all the different variations and why really this. He starts. It's really kind of funny. He says, "This matches, I claim, any email address. Most of the feedback I get refutes this claim by showing one email address that this regex does not match. Usually, the bug report also includes a suggestion on how to make it perfect." And then he goes through and explains that really the full collection of email addresses, it has all kinds of crazy stuff in there that nobody ever uses, and so you can go crazy or you can use this. But we already saw an oddness. Anyway, everybody gets regular expressions. If you now look through the API or the methods on the string class and many other classes, in particular string class, you'll see a whole lot of different regular expression related methods. So if you're trying to parse something, pull parts out of it, remove, modify it, like you have something with a dash, you want it without a dash, whatever it is, and the simple techniques don't work, the regular expression is your friend. Okay? All right, next. Let's talk about sessions. The web server is stateless. Who wants to explain what that means? Because I've said it a million times. What does it mean? As succinctly as you can say it. George.
Between two states, the server forgets what was in the first one.
Right. Or whenever each request is handled independently. So, whatever happens between requests goes away. That has to do also with the topic we had the other day about background processing, how you couldn't run a process, in a thread inside the web server because once the request passes, the process would go away. So basically every request that comes to the server is handled from scratch. Okay? So people talk about sessions as a general topic. I mean, it's a kind of a colloquial term. And people talk about sessions timing out, and people talk about the thing remember your session. And basically, it is whatever additional mechanism can be added to a standard web server and browser combination to overcome that stateless fact, that stateless architecture of web servers, of HTTP in general. So it's simple things like who's logged in, or what's the item you have in your cart, or even the fact that you looked at a certain brand of shoe, so that when you go to Facebook, you get presented with an ad for that shoe. Those are all parts of the overall notion of session. And that, by the way, is a real scenario. In fact, both Google and Facebook have elaborate mechanisms to allow it to simplify the process of presenting you ads based on what sites you visited an hour ago, before you ever got to Facebook or Google. And they use sessions in the broad sense, usually cookies, but there are other ways of doing it. Okay, so you basically have to remember information from visit to visit. And we talk about the session state in that context. And the session state basically is nothing more than a set of name value pairs. So it could be something like, user, well, something as simple as, a login ID, but that's really bad because that's not good architecturally, but it could be anything. And in fact, we can just look at this way the cookies that I have here to see what cookies this particular, so there are none. Okay, that makes sense because I don't put any cookies. How about here? What does Rubular do? What kind of cookies is this collecting about me? Cookies. Okay, so it basically has the fact that there was a Rubular session even though I never logged in, and then it's got these weird things, UTMA. Anybody know what they are? When you see something you don't know what it is, you Google it, right? So let's Google it just for fun. Underscore UTMB. Let's see what it is. Huh? But there's one. Oh, there's. Just tell me what it is. Google Analytics. Okay, so they're tracking Google Analytics. So this guy, obviously, he wants to know how many people are visiting him. So those are cookies. So going back to this, let me close this. So basically, a cook, and in those cases, in fact, let's go back to this really quick. We see that it's a name, underscore UTMA, and some mysterious number. I don't know what it means, but Google will know. So when
What about the domain?
Okay, so the domain is technically just another part of the cookie, but in practice, it's used to when the client returns an answer from a server, it will return with that answer all the cookies that were assigned to the domain being that is making the request. So it returns them all. So whenever the domain, I guess .rubular means star.rubular.com. I wasn't sure about that. Makes a request, it's going to return to the server not only it's going to return to the server all the cookies, i.e. these cookies that were recorded last time a request was made from that same domain. So the effect is when I visit a Rubular site, right, all those UTMA things get sent to the server, and he's going to do something with them.
But the domains are generated by the browser.
By the browser.
Otherwise, I could write some cookies for Facebook, although I'm not.
Exactly. Yeah, they're generated by the browser. But there's, all these things are, you can look at it at the top level of the sort of the pure case, but then you can be sure there's all kinds of additional complications having to do with caching and security and cryptography and so on, which I'm not even touching on. Okay, so it's a set of name value pairs. Remember that. Don't focus on cookies. It's a set of name value pairs because those name value pairs do not necessarily get stored in a cookie. There's many different places to store them. Now, cookies are the easiest because all browsers support them, and they are very fast and very simple. But one problem with cookies right off the bat is that cookies are a feature of the browser. So if you access the server not through a browser, like through a REST API, there are no cookies. So you have to sort of consider what you're going to do in that case. So the session, in fact, I'm not sure really what the notion of a session does if you're not talking HTML. For further research, yeah.
Another thing is local storage
Local storage here or on the server?
on the client. I think that works in beyond browsers.
Yes, but that's not, that could be used for that. You're right. It could be, so this is HTML5 business. You mean the data tags? Yeah, that's true. That's another option. The two big cases though are cookies. Now, one of the problems with cookies is that the stuff is actually stored on the client, which is a security hole, right? If I put the password so I don't have to type the password again into the cookie. It's now getting recorded on the client. So now, unbeknownst to you, all your passwords are being stored in clear text, essentially, in a file, essentially, on your file system. Not good. So the other model that is used is storing it on the server. And storing it on the server means it's very simple. Instead of a cookie containing everything you have, the cookie contains a unique ID, what we call a GUID. Everybody heard the term GUID? Stands for Global Unique ID. It's a large random number, and that is assigned by the server to the particular client. And from that point on, that GUID will be an index into a database on the server with all the information. So all you need to do is session ID equals blah, 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 and that goes in the cookie, but it's meaningless. But when that number gets sent to the server, it can look up on the database to find basically the name value pairs. Yes?
But doesn't that have the same problem? The same security problem where...
Well, now a magic number is being stored on the client, not the actual details.
But that number gives you the actual details.
Assuming that you could get the server to return them to you, and the server has no way to, because let's take a login. The server might simply see that you were logged in, looking in this database, and then cause you to be logged in on the database, on the server. Nothing has to be sent back to the client.
Gotcha.
Okay. Okay.
Question.
Yes.
So I did not quite get the answer to this question. So if you are logged in and you get a session ID, it was Git.
Yeah.
And then I copy this cookie to in another browser, like
Right.
to Evan's computer, and he plugs it in, so he will be also logged in as me.
No, that would be a bug. That would be a bug. So in other words, there's a lot of different ways you can prevent that. For example, you could encrypt into the session ID or put on the server side in that database the IP address from which that request came, the time when that request came. All those things can be recorded as part of the same session.
But if
So-
I don't do that, then
Yeah, you have to definitely, this is a very ripe area for security holes. I mean, there used to be an easy thing where I would email you my session ID, which was actually sitting in my URL. You've seen URLs in the past, # session ID equals blah, blah, blah. I would email it to you, and now you would be in also. That doesn't work. I mean, unless you have a very badly designed site, that doesn't work anymore. So you can imagine encrypting the stuff in the cookie, even if it's stored in the browser. You can imagine encrypting the stuff in the session information when it's stored on the server. You can imagine putting in timestamps to make sure that the thing is only good for a certain amount of time. And you can imagine making sure that the IP address is what you want. Now, IP address can also be spoofed, because you can make your particular computer look like it has a different IP address. So it's a classic, spy versus spy kind of battle where one hole opens and they close it. But that's the basic scheme. Another thing about cookies, so cookies are really simple, but there's a limit of how big they can get. I don't know what it is. Is it 128K, something like that? They're not small, but there is a limit. And there's a performance problem because you're sending this stuff back and forth all the time. So the other rule of thumb is that you don't ever put whole objects into a cookie, into a session. Okay, even if it's a session stored in the database. I mean, again, all rules are made to be broken, but what you do is you put an ID, something that uniquely corresponds to the object that you want, but you don't put the whole object. Okay? So, and Rails built into it, there are 3 different kinds of session stores. I mean, actually there's more, but these are the 3 most important ones, and I'm going to show you with the code sample in half a second how all this works. But you can tell it that you want to use the cookies as session store. You can tell it that you want to use a special database table as your session store, and you can tell it to use a memcache, which is a memory-based, a network-based cache. Okay? So let's take a look at how all this stuff works. Don't tell me I didn't git clone it. Okay, bear with me for half a second. Thought I had that ready. Oh, did I hide it? I think oh yes, I hid it inside a form demo. I remember now. Ah. Okay. again. All right, so let's look at a few things. So first thing I did was I went into config initializers session store, and I changed the default. I'm going to change it back. So these are the lines that are involved. Either I say I want to use the cookie store, which is this is the default, or I want to say the session store, the active record store. So when I do this, now I'm going to look at a controller called, I think I did it in the category controllers. Yeah, I'm pretty sure that's where I did it. Let me think here. It's not in the item controller, is it? Well, we'll do it over. I am in the right. Let me just search for sessions. Yes, 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 yes. Oh, okay, I guess, odd. Must not have checked it in, but that's okay. So I'm going to go back here, and I'm going to say, let me just leave it like this for a second. And I'm going to run my server. Okay, I'm going to say bundle. I want to run the server. Good. Go to my browser. I'm going to type this. And I forgot to do a migrate. Okay. Great DB migrate. Yeah.
Oh, I know that one.
What?
I know that one.
All right, let's see if we're happier now. Oops, we got to run the server again. Okay. Now if I go to categories, I'm going to hit that breakpoint that I set. There it is, binding.pry. So if I look at session here, oh my God, that's a lot of stuff. So if I say session.keys, I can see that this session has two keys, session ID and the cross-site reference to it. This is a security thing. Anyway, it doesn't matter. It's a security thing. But there's nothing else stored except for the session ID.
Request forgery.
Thank you. It's request forgery. And if I say session ID, you see that there's the session ID that was assigned magically by the Rails server to me. But what if I say session/hello equals pedo? Does that work? And now I say continue. Okay. I'm guessing here. I'm not sure really that's going to work, but let's go check now in my cookies. And it does not have it, but let me do it again. It does have the form demo session, and it does have this remember token, but does not have the one I added. So instead of this, I'm going to go to my code, and instead of binding.pry, I'm going to say, maybe I have to do it again.
Did you return to the browser?
I think I did, yeah. And now I go back to the browser. I refresh this. Everything looks fine. Oops, sorry. Where do I want to be? I want to be here. Sorry. And it's not showing up. And the reason is maybe I had to restart my. Did I actually change that? Let me just see what else here. Session store. I did change it to that. It does have that.
Should it be inside the demo from demo session?
Cookie?
I'm sorry? Oh, I thought I had it in the categories. Did I have it in the demos? Let me see.
No, I mean it should be. It should be inside the from demo session key. In that value somewhere.
No, I don't think so. I think it stands by itself. And
The names are also different. Your names were not from demo session and remember token.
Yeah.
Oh, they're different?
Yeah.
That's pretty fishy, isn't it? Let's see here.
And the session ID and the other one is security sync.
Okay, who can help me figure this out? Categories. Let me just settle that again. Let me look in here again. Controllers. Categories controller. That's correct. Now, let me just do this for the fun of it. Put S pound curly bracket session. Hello. So we have a little bit log output there. But then we wanted to check also. Okay, so now I kill the server. I'm going to restart the server. And I put it under show, so I have to go here. Oops, sorry. I'm going to refresh this. And there's no cookie yet. Yet if I go to show, which is this.
What's the red exclamation point?
Oh, that's interesting. Oh, WebSocket. That's because I haven't set things up correctly on that side. Don't worry about that right now. Good catch, though. So if I go to particular, let's see if the server printed out. There it is. So there it is. It did get it. It is in the session, but for some reason it's not storing the session in a cookie in a place that I can see it. And not sure why, because it is picking it up. You see here? So the mystery is why.
The names of the cookies are also different than the names.
Really? That's so weird, isn't it? Maybe the browser is misbehaving. Can we blame the browser? What?
You can always blame.
Ah! No, not yet. These numbers are all different, you're saying, huh?
Well, no, it's like
No,
the
like
form
the-
demo session. That's
Not the name.
not the.
anything.
Yeah, we named something session and we named something else CFR.
Oh, I see what you're saying. Cookies, local storage. Well, the form demo session is coming from here. If you look
Yeah,
at,
so it in the initializer.
yeah, it's in the initializer. It is in the initializer.
So it's in the, everything goes in there.
Yeah.
But if you do session keys again, then you will see that the keys are named different than the ones in the cookie.
Interesting. I'm going to exit the browser. When all else fails, restart the browser. See what happens. Still doing okay on time. Okay, I'm going to go to categories. Okay, I'm going to look in here. Nope. So form demo session, that we know is because of this. If I go to config, initializers, session store, there's form demo session. And it's saying cookie store, and it's not commented out, and I did restart the server, and I did save this file. A little mysterious, but let's switch it around now and do this.
So then, but where does the sessions, that hash, what is that in then?
That hash that I'm using in the controller?
Yeah.
Okay, it's kind of a fake hash. It's something to make it look, well, let's go look at it to see how if it is a fake hash. I'm pretty sure it's a fake hash. In other words, something that behaves like a hash, but actually does a lot more. So if I go to categories controller, and I put a binding pry here, and I refresh this, and I go here, and if I say session.class, I see that it is an action. It's a request session object. You can hardly see it, but
Yeah.
okay. So it's a magic object that looks like a hash, but the effect is that whenever I store into it, it's supposed to trigger the whole avalanche of effects, which ends up storing the thing in the cache. So let's go now and take a look at.
Maybe it has something like a save, like a storage.
No, I got this to work when I was, putting in these lines of code yesterday. So it's something small, and when I figure it out, I will send you guys an email. But until then, let me get rid of this binding pry, and exit from here. Restart the server. Okay. Now it should be using the active record storage. So if I do the same thing again, first of all, let me call my Mesa SQLite and open it. Ah, no. I had one that I, shoot. All right, this is not gonna work. Think.
SQLite problem.
Well, it's not a problem. It's that I have the older version was free, and I still have it on my other machine, so I've moved the older version to here. But I must have done.
Rails console?
Huh?
Don't you use Rails console?
Yes, I can. That's a good idea. That's a very good idea. Thank you. cd/mydev/form demo Rails console, and we can look in here to see that we have a database that was created. We look at the in the schema, we see that there's a database here called sessions, the table called sessions. This database is created by virtue of this command that is also part of the setup. This command here, Rails generate, so when you add this gem, to start doing the session in the database, you do this command which creates a database, you do a migrate, and you modify this initializer, and that enables the whole thing. So there should be a table now called sessions, as we can see from this. The object will be, oh, interesting, I don't think there's a class for it. Still going to be interesting. I seem to remember now that if I go here and I go session, it's not there. So it's a database without a
model.
Without a model, right. And there's ways of doing this, like running SQLite on the command line, but I don't know how to do it. No. Okay, well, you have to take it on. That sucks.
Take any other model and then do dot connection dot select all, and then you can enter vanilla SQL.
Oh, okay. So you're saying, for example,
Any other model?
Items?
yeah, item dot connection
Yeah.
dot
Select underscore
all,
and then open, yeah, and then select star from.
select star from sessions. I should be in Pry, otherwise it's not
Yes.
going to work. That's kind of cool. No, I should be in Rails console. Okay, and there's interesting. So that's, do I have to say that all again? No. No. So what is this saying? This saying that there's nothing. It's empty, correct?
Yes.
Is that how you interpret this?
Yeah,
At row,
rows
yeah,
is
okay,
zero.
rows is zero. Okay, so
Kinda
now let's go run the server again if it's not already running. Let's check. It is running. Now let's go to
William, I did this research just for you. We don't need it in our app. I read your question.
categories. Okay, so now I'm feeling this isn't going to work either. Do it again. There's the row. Of course, it's all encrypted, so you can't read it. But there's a row. You can see rows. There's the row. There's the 80s. All kinds of gibberish, which corresponds to the pedo equals hello. Okay. Everybody following what I just did? Kind of. You want me to repeat it? I'm seeing blank stares. Yes. Yes. Thank you. An honest. There's still an honest man. So here's the sequence of events. I put into my Rails server, I updated one of the controllers, in fact the categories controller, to store inside the session under the key hello the value pedo. All right, so this should create a session with the value pedo under the key hello. I proved that it works by printing it out in a different action, which is sort of another request, and it shows up in the log that it worked. The question is, where was that string pedo stored? There's two scenarios. One of them is that it gets stored in a cookie inside the browser. The second scenario, which I just demonstrated, where you enable the active record session store, instead of storing it in a cookie, it gets stored in the database. So the sequence goes something like this. See if I can draw. The browser calls the server, requests / categories. Okay? During the execution of this, the server decides to store a cookie.
I can't read.
Huh?
I can't read.
Move.
You can use the right one for your
They're always just as bad. I'll write over here, especially for Bert, because he had the question. So here we have the client and the server. The client says, please give me / categories, which calls the index action on the server, which includes session, whatever it was, name, greet, whatever it was, equals pedo. Now there's two ways that it can decide where to store, and then it's going to return back to the browser. So that'll be the end of the request. It can store it in a cookie, in which case it would be sent back over here. So the browser would store it in a cookie. But when you enable the active record-based session store, now instead of that, it goes into the table on the server called sessions, and indexed by a session ID, it puts a encrypted value, which essentially is p greeting is pedo over here under my session ID, and it returns just the session ID over here, which is stored in the browser. Then the next request comes along, and I say something else. Let's say just say categories again, which sends the request over here. Well, let's call it categories /3, which is now going to execute the show action. And before the show action starts executing, the browser, which has sent the session ID back, because it always sends it back, it uses the session ID to look it up in this table and initializes the session hash back to the way it was before. Greet pedo. So when this action executes, it's as if this thing stay around all along. So the question here is just, where did this greeting equals pedo get stored? Scenario 1, it gets sent back here and stored in the browser. Security problem. Scenario 2, just a session ID gets sent back, and a database is used to store this data. Yes?
Does that record get deleted from the database table?
Very good question. Complicated answer. Cookies have a time to live when they are deemed to be invalid, but there's also, in terms of good software engineering practices, you have to clean up your cookies. One of the attacks on servers at one point was a session ID attack. I mean, if every time a session comes around, your architecture decides to store a megabyte of information, like your picture, in the session store, and people just start, ramming your session with session opens without anything else, it could overload the server with a lot of session information. So cleaning up of the session database is also an issue. That's one advantage with storing the session in the cookie, because the session data all gets stored on the client, so it's not the server's problem. The problem is that now, a bunch of data is going back and forth. That's a performance issue, and the problem number 2 is that stuff there may be a security problem. Okay, and so you can imagine the general principle here is just, I set a value in the session in one action, and I want that value to magically be around again in the next action. And the options are send it to the client so he can send it back to you, or put it in a local database, and there's a few other options. It could be in the file system of the server, which is a bad idea. It could be on a separate server inside of your server farm, which just does caching of sessions. I mean, there's a lot of options. But the basic need is simply, how do I store that? Because when I come back in the next action, I want to have it again. Yeah. Thanks for asking that question, because I think it gave me a chance to explain in more careful detail.
So if we, in addition to just the session ID is stored automatically in the cookie, right?
Yeah.
Even if I say not cookie but active record,
Yes.
it still stores a
Yeah.
cookie. With
It needs some anchor to use.
Right, and if I do cookie, then it stores whatever I have in the session.
Yes, exactly.
And regarding the performance thing, if I store, let's say, I don't know, 5, 10 name value pairs, right?
Yeah.
Name and an ID as well.
Yeah.
It will.
Nothing.
It's nothing. Right?
Yeah, it's nothing.
So it's
For our, by and large,
like serializing objects and stuff within the cookies.
in the scale of things, it's nothing. One of the 100 habits of effective software engineers we'll cover on Friday is don't optimize too early. Wait until you have evidence of a performance problem before you write any code to make it faster. because almost always the thing you think is going to be fast is going to be slow, and the thing you think is going to be slow is going to be fast. So wait until you have evidence of a performance problem and then go fix that. So that's, I would say, cookie, 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 unless you have a reason to go beyond that. But now you see that Rails makes it super easy to do. And by the way, next year when I teach this course again, I'm very likely not going to use Rails. I'm going to use Node.js. And one of the things we will discover with Node.js is you'll learn to appreciate Rails, because you have all this plumbing to do all this stuff, which is there because Rails has been around for like 10 years, and Node.js is brand new, and a lot of stuff you have to do by hand. So you do a lot more coding, a lot more boilerplate, and people will say, well, at least I know what's going on, which is true, but your programs are much longer, and also all the code, every line of code you write is a place where you can have a bug. So, so appreciate this mechanism. It's very, very sophisticated. It does a lot of stuff that is common, that has been discovered essentially. I mean, the whole world of cookies, it's not like somebody said, I'm going to come up with a scheme to do sessions. It wasn't that like that at all. It was more like, oh, we have a shopping cart. Geez, how do we do this? Where do we put it? Oh, well, let's invent this thing called cookies. Just be a bunch of little files, and then they have cookies, and they go like, oh, well, what about security? Oh, let's encrypt it. And that's how these things evolve based on, it's like, the expression is paving the cow paths. Have you heard that? Paving the cow paths. It's making a street out of where the cows walked. People say that Boston, if you've been to Boston, the streets are all very crazy because Boston was a town long before there were any vehicles. It was not a design town. So basically the streets appeared where people walked and where the cows walked. And then they put pavement, paving the cow paths. So that's the same thing in this world. I mean, people just saw what the techniques were that seemed to work, and then they start building frameworks and tools and tooling to make those easier to do. Okay, done with this. Let's move on to the last topic, which I think I can do quickly. Let's talk about mocking. So basically, the reason that mocking is a thing is this. Once you get a little bit deeper into writing tests, you will discover very quickly that if I'm testing class A, B, C, that in order to test it, I'm going to also run code in class XYZ and XYZ prime. So in other words, there's a class you're testing, and they call it the system under test, the SUT, it's sub, but it's a class you're testing, and then all the other classes, one or more, which are the collaborators with that. And that's okay, but it can lead to a certain class of problem. Overall, another of the 100 habits of good software engineers is decoupling. You know, as much as you can, make bits that are independent. If I look at a source file and it starts with a bunch of requires, like a bunch of requires, I know this is heavily coupled. I know that this person said I couldn't use this particular module or this particular source file without also putting in that and that and that and that. That's a sign of not great architecture. What you want really is a class that stands on its own. So decoupling is a good thing. So what happens when you have a system under test, and you're trying to test whether the warehouse class, which is a very complicated class that's fetching, you know, running robots in the warehouse and, you know, running the heat and whatever else, is needed simply to test whether the order class is properly placing an order. So you have an order class which is very simple, and it's want to place an order. It sends one little message to the warehouse that says, do you have this book in stock? And for me to test that little method, I have to create an instance of the warehouse class, which is a big monster. And now when my test fails, it's kind of hard to be sure why it failed. Was it a bug in the warehouse class, which I wasn't even testing, or is it a bug in the order class? Okay? So that's where the notion of mocks comes in. Now, mock is fake, right? And you'll find a lot of wacky terminology. People talk about mocks, they talk about doubles, they talk about stubs, they talk about fakes. And it's confusing because the terminology is still settling. People are still debating what these things mean. So I'm going to just say mock. Okay, and a mock is simply an object that is made to appear and function as if it were a different object. So I can make my mock warehouse class, right? It has only one method. And the method is, given this book number, tell me if it's in stock or not. And it returns based on some other parameter, like books, you know, the numbers start with 1, it'll always say they're in stock, and books the numbers start with 2, it'll say it's out of stock. That's all it does. It's standing in for the real warehouse. Because if I want to just make sure that my order method on my book class is working, that's really all I need the warehouse class to do. So I create a mock warehouse that has only that behavior that I need to run my test on my book. And there's several ways to handle this problem, and there's some that require additional tools, some that you can just come up with in your own mind. But the basic principle to think about is when I'm testing something, to try to isolate the test. Now, a few reasons why that's good is, number one, performance. I mean, when you find that your system has 100 or 200 or 500 or 1,000 tests, you start caring about performance. You start caring about whether it takes 6 hours to run the tests, or whether it can be done in 6 minutes, or whether it takes 6 days. So performance of tests is a real issue in real engineering. And so mocks are a way to get performance, because you don't have to gen up this whole warehouse class every time for every test. That's one. The second reason that's really important is that if you have a failure, if the test does not succeed, you don't have a mystery as to whether you happen to have stumbled on a bug in the warehouse class, because you weren't even testing that. Okay, you know that the bug is going to be in the system under test, in this case the book. So those are two strong reasons why to think about having mocks. The one disadvantage, and this happens no matter how you go about testing, and people realize, is that in a way, I mean, how many of you have written tests for your apps? Okay, so about half. So you'll find, why are you guys laughing?
George.
I just said, I didn't make a distinction. How many? The point is, once you start writing tests, so George, I'll take you as you will find that sometimes you basically feel like you're maintaining the same algorithm twice. Once in the app, and once in the test of the app. So that if you decide that instead of requiring a string, I think this method should require an array, you have to first change the method itself to handle the string, the array versus the string, and then you have to go change the test, because it now has to supply the right parameters. So you do end up with, well, whatever, but you have two things that are in sync. And so that is one additional overhead, but the wisdom is that it does pay off. But just recognizing that. So let me just show you. These are really good articles, by the way. I recommend them. Minimalist. Both of these are very good. But let me just show you my doubles demo real quick. I won't even run it. I'll just show it to you in code. Okay. So basically, I have. This is not the warehouse thing, but basically I have a class called order. It's very simple. It creates an array called items. Whenever you add an item, it adds it to that array. It has a method that computes a total, which does it's one of those. It basically iterates over the whole array and computes the total of the prices. Okay. So how am I going to test that? Well, this is actually a mock, essentially. Rather, this is the actual thing. Okay, let me just go on instead of that. So now I'm going to look at my test. And I want to basically test. So this is the, sorry, I'll go back. This is the order, and that's what I'm testing. But in order to test it, I have to have items. And let's imagine items, which are the things being ordered, are this big complicated class that has books and images of the author, and they can be read out of a database, and it's just a big hairball. And all I want to do is check to see whether this order thing works or whether the gross total works. That's all I want to do. I don't want to pull in that whole item class and set it up in the environment and everything else. So here's what I do. In my before block, because it's going to end with this, order gross total must equal 18. I create an order. That's that class. Now this is a little technique. I just put it in here to show it to you because it's very handy. If I want to create a bunch of objects, one handy thing to do is to create an array with the parameters you need. So I created a two-dimensional array. At the first level, it corresponds to each item. So there's 2 items here: shoes for $12, socks for $6. And then I iterate through this item info list. And for each one, I use item info 0, which gives me this, and item info 1, which gives me that. That's just a technique if you want to create a lot of data quickly. This is a by the way, a version of test fixtures, except these test fixtures are built right in line with the code. Anyway, but here's the important part. I say item equals, and this is the magic line. This is just a tool called mini test mock. I create a new mock, and I tell this mock, expect to be called with a method called description And when you get called with a method called description, returns item info 0. So either shoes for the first one or socks for the second one. And then it said, oh, in addition, item expect to be called with a method called price. And when you get called with a method called price, return this. So now I've created 2 items, which are not based on the real item at all. They're mocks. But they know how to respond to these 2 methods. One of them responds with the description and price of one item, the other one with the description and price of the other item. Okay? And now I invoke the real order class over here, and I just say add item. Okay? And I'm adding a fake item. However, this guy doesn't know, because all he cares about is that the item he gets is able to respond to object.price, which my mock can. This code is going to be fully tested without any apologies, even though I never used the actual item. Okay? And then finally, the actual test line, it can calculate items due at order, which was set up in the before block. Gross total must equal 18. I just added mock. That's a mock. Okay, so that's the tool. Avoid coupling in your code in general, avoid coupling in your tests, and watch out when you have to set up some big monster object that has nothing to do with the test you're doing. Think about using mocks. Okay, yeah?
Is there any way to set up the test database and keep it between the tests? Because what I realized is, well, first, if you use fixtures, then you have them in a separate file.
Yeah.
And it loads them, but it does not always care about all these dependencies which you define in the model.
Yeah.
Or at least I think so. And second, it like swipes out the whole test database and
Right.
then fills it
Yeah.
again before each test.
Well, there are many different ways at that problem. I mean, certainly, building fixtures in the Rails way is one way. There's other tools, but I found generally that what I prefer doing is to write the setup of the data as a set of methods that I can call with the test. So instead of building it into a database that's fixed, unless there's a performance problem, or you can do your testing with the objects just in memory, not in the database. So you can just do a bunch of object.creates, and build them in memory. So there's a variety of techniques is the answer, and it depends a little bit. I mean, you'll have to try them each and see which one you like better. I've tried them all, and I ended up with this technique generally, which is sort of create what I need with the test and then use it. But there's other times when I don't do that. So that's not a really good answer because there's not a straightforward.
I had big problems with fixtures because I need some data for one test and
Yeah.
some other data for the other test.
Yeah.
And therefore the Rails is fixture all.
Yeah.
So it loads all of them. And so I have to think when I write the must equal
Yeah.
for one test,
Yeah.
I have to think of all the other fixtures which exist for all the other tests.
Yeah.
If they will not interfere with what I expect in this test.
Yeah,
It's kind
that's
of
not a
messy.
good situation to be in. There's probably a better way to
Then
go.
I like swipe all the fixtures.
Anyway, we're done. Just a quick reminder. So Thursday, lab all the time. This time, same preparation. Write the same sort of summary of what you've done, what you want to do. Demos come first. The first thing we do is demos. So, get it ready as good as you can for the demo. I have notes of what you guys said you were going to have done by Thursday, so I'm going to be checking. Although it is what it is. But I just want to know. I'm hoping you guys go for what you said you would.
No.
Okay. Thanks.